Hello folks, today we're going to talk about Reynolds number, what it is and where we can use it. So a Reynolds number is a dimensionless value which can be calculated based on the fluid characteristics and a body characteristics which moves in that fluid, and it describes the level of turbulency of the flow. So it can be calculated using this formula where Reynolds number equals to rho VL divided by Greek letter mu, and division of the Greek letter mu over rho equals to Greek letter of nu. So basically we have a rho as a density of the fluid, V as a velocity of the fluid, L characteristic length of the body which moves into the fluid, mu as a dynamic viscosity, and nu as a kinematic viscosity. So finally you see the formula in the center, Reynolds number equals to VL divided by nu. So you get basically on top all the inertial forces, and on bottom you've got viscous forces. Just to make sure, characteristic length in various cases is different. Simply saying the maximum length of the body which we are analyzing. So in case of ball or any kind of cylinder, it will be a diameter of that ball or cylinder. And in case of airfoil, that will be chord length. There is an amazing Moody diagram which shows on specific values of Reynolds number if fluid can be characterized as a laminar or turbulent or somewhere in between in a transitional mode. Here you have an amazing website called the Engineering Toolbox, which gives a really nice table where you have all these parameters. The most important, what we mentioned, the density and the kinematic viscosity, and they are given based on the elevation from sea level. So here you have the elevation, and the good thing about this table is that it's given in a metric system and the imperial system as well. And if you actually want to calculate Reynolds number super easily, you can go to the website we already know, Airfoil Tools, where you have Reynolds number calculator here. And here you have the actual online calculator of the Reynolds number. Let's say, for example, we are moving in the air by 20 meters per second. And the chord length we have, for example, 0.5. And we are interested what value we should have for kinematic viscosity. We go back on this website. Here is the kinematic viscosity. And for example, if we are on a 5,000 meters altitude, kinematic viscosity for that will be 2.211. But make sure this value is given as a 10 by minus 5 to be written there. So you shouldn't write just that value here, but you should copy just those numbers which are in front of e minus 5. If someone doesn't know, e minus 5 means 10 in the power of minus 5. And then press calculate, and that gives you Reynolds number. Thanks for watching. Please subscribe.